Here the problem is you have to calculate percentage composition of a compound by its weight. The compound's total weight is the 0.24 grams. That given compound's sample containing 2 atoms or elements, those are nothing but here oxygen and boron. The boron atoms or elements weight is the 0.96 grams, and another atom or element is the oxygen, that one's weight is the 0.144 grams. So you should calculate this particular weight's percentage composition. That percentage composition formula is the mass of element or atom upon mass of compound, or total mass of compound into 100. This is the formula for the percentage composition. So now you can substitute these values. First of all, I am going to calculate about the percentage composition for the boron. So for boron, percentage composition is equal to, what is the mass of boron atom or element is here 0.096 divided by, what is the complete compound's mass, 0.24 grams into 100. So by multiplying with this 100, 0.096 will become 9.6 divided by 0.24. Then you can multiply numerator and denominator with 100. So you will get 960 divided by 24. Here see, 24 fours are 96, then 0. That means 40% of boron is present in the 0.24 grams of sample containing compound. So then coming to the calculation of oxygen's percentage, oxygen weight is 1.44 grams upon complete compound weight is 24 into 100. Then this 1.44 will become 14.4 upon 0.24. Then again you can do multiplication numerator and denominator with 100. Then you will get 1440 upon 24. See, 24 6 ja 144, then 0. See, this is the 60% of oxygen present in the 0.24 grams of compound. Actually, by calculating first elements percentage weight, then after you can directly calculate second elements percentage weight. How can you calculate that? See, the complete compound's weight is equal to 100 percentage. If 100%, then 100 minus 40 will gives you 60% of second elements mass percentage weight. Here the problem is you should calculate weight of carbon dioxide formed during a chemical reaction. The problem is, in the first condition, 3 grams of carbon reacting with 8 grams of oxygen, they will form 11 grams of carbon dioxide. Then in the second condition, the same amount of 3 grams of carbon reacting with 50 grams of oxygen, then how much mass of carbon dioxide will be formed? Then after, your answer going to be justify which law of chemical combinations. You have to tell that one also. Now going to the calculation part. See, carbon reacting with oxygen gas, then they will form carbon dioxide. In the first condition, 3 grams of carbon reacting with 8 grams of oxygen, they will form 11 grams of carbon dioxide. Here from reactant side it is 11 grams and the product side also 11 grams. So here, that means by seeing this answer, you can directly tell this condition is represents about law of conservation of mass. Law of conservation of mass is nothing but how much mass is going to be reacting in that chemical reaction. During that chemical reaction, that much mass will going to be generated. That is nothing but law of conservation of mass. This is the first condition. Then coming to the second condition, 3 grams of carbon reacting with 50 grams of oxygen, then how much mass will be generated? See, here 3 grams, here also 3 grams. So that the 3 grams in the previous condition reacting with 8 grams. That means here also the 3 grams of carbon reacting with 8 grams of oxygen. So here 42 grams of oxygen will be the leftover one. It will not going to be reacting with this 3 grams of carbon. So here also 11 grams of carbon dioxide will be formed. Same, by seeing this reaction, you can conclude the second condition obeys about law of constant proportion in a chemical reaction for the formation of a compound. First condition, law of conservation of mass. Second condition, law of constant proportions. Here it is a question number 4 from your exercise. You have to write molecular formulas for all these compounds. See, magnesium chloride is nothing but MgCl2, calcium oxide is the CaO, and copper nitrate CuNO3 taken twice, and aluminum chloride AlCl3, and calcium carbonate is the CaCO3. This is the question number 5 from your exercise. In that one, first one is the quicklime. I mean, for all these 4 bits, you have to identify which atoms are present in their molecular formulas. So, first of all, you can see quicklime formula is the CaO, nothing but calcium oxide. So, here in this calcium oxide, calcium and oxygen atoms are present. Baking soda is nothing but NaHCO3. In this NaHCO3, atoms are sodium, hydrogen, carbon and oxygen are present. In the same way, hydrogen bromide is the HBr. In this HBr, hydrogen and bromine will be present. Potassium sulfate, K2SO4, its molecular formula. So, potassium and sulfur and oxygen will be present in the molecular formula of potassium sulfate. This is the problem number 6 from your exercise. You should calculate molar mass for all these compounds. This is the first one is the ethine. Its molecular formula is the C2H2. So you can write like this: 2 carbon atoms plus 2 hydrogen atoms is equal to 2 into 12 plus 2 into 1. 24 plus 2 means 26 grams. It is the 26 grams for ethine molecule. And sulfur molecule, it is in the form of S8. Sulfur's atomic mass is the 32. So that 8 atoms of sulfur is here. So 8 into 32. 256 grams or 256 U. Anything you can write. And this is the phosphorus molecule. It is in the form of P4 state. So that phosphorus molecular atomic mass is the 31. So 4 into 31. 124 grams. Next, hydrochloric acid, HCl. Hydrogen molecular atomic mass is the 1 and chlorine's atomic mass is the 35.5. So you will get 36.5 grams. Then nitric acid, HNO3. hydrogen's atomic mass is the 1 plus nitrogen's atomic mass is the 14 plus 3 oxygen atoms are there into 16. Here see 15 plus 48. See 5 plus 8 13 1 63 grams of HNO3. The question is mass of 1 mole of nitrogen atom. Atoms he mentioned, so that single nitrogen atom's mass you have to take. So that 1 mole nitrogen atoms mass equal to 14 grams. Mass of 4 moles of aluminum atoms you have to calculate. We already know aluminum's atomic mass is the 27. So 1 mole of aluminum equal to the 27 grams. See, 1 mole of aluminum equal to 27 grams. Then 4 moles aluminum equal to how many grams you have to calculate? 27 into 4 upon 1. So you can write this one. 108 grams. 4 moles of aluminum equal to the 108 grams. Here the problem is, what is the mass of 10 moles of sodium sulfate? Sodium sulfate's formula is the Na2SO4 and its molecular mass is the 126 grams. Remember this one. So, same formula like that 1 mole Na2SO4 equal to the 126 grams. Then 10 mole Na2SO4 equal to, you should write 126 into 10. So 1260 grams weight for the 10 moles of sodium sulfate. Here the problem is you have to calculate mole number. In previous case we have to calculate about mass number if mole number is there. Here mass number is here, so you have to calculate mole number. So first of all you have to take oxygen gas. Oxygen always present in the form of a gaseous state. That gaseous state oxygen having molecular formula is the O2. Its molecular mass is the 32 grams. Now you can calculate this 32 grams of oxygen gas is equal to the 1 mole. So see, in the problem 12 grams. 12 grams of oxygen gas is equal to the how many grams? Again cross multiplication, so that 12 divided by 32. Fourth table you can use 4 3s are 4 8s are 3 by 8. Next 8th table. Point you can take 8 3s are 24. Next remainder is the 6. 8 7s are 56. 4 is the remainder. Next one is 8 5s are 40. This is the mole number. See, nothing but 32 grams of oxygen is equal to the 1 mole. Then 12 grams of oxygen gas is equal to the 0.375 moles. Here the problem is you have to calculate mole number for 20 grams of water. See, this is the molecular formula for water. What is the molecular weight for water? That is 18 grams. So you can write 18 grams of water molecules is equal to 1 mole. Then 20 grams of water molecules is equal to how many number of moles you have to calculate. Here also cross multiplication you have to do. So see, by doing cross multiplication 20 divided by 18. So 2 10s are 2 9s are. Ninth table you can take 9 1s are 9, again 9 1s are 9, 9 1s are 9. So it will continue, so that This is the 1.11 mole. See, 18 grams of water is equal to the 1 mole. Then 20 grams of water is equal to the 1.11 mole. See, here the problem is, what is the mole number for 22 grams of carbon dioxide? Here carbon dioxide molecular formula is the CO2. Its molecular mass is the 44 grams. So this 44 grams of carbon dioxide is equal to 1 mole. Then 22 grams of carbon dioxide is equal to how many number of moles you have to calculate. Same old story, cross multiplication. 22 divided by 44 will gives you 1 by 2, means 0.25. This is the 0.5 mole. Nothing but see, 44 grams is equal to 1 mole, 22 grams is equal to the 0.5 mole. By seeing this statement, you can directly tell 44 is its molecular weight. That molecular weight is equal to the 1 mole. So that 22 is the half of the 44. So that you can directly write 0.5 mole. The problem is you have to calculate mass of 0.2 mole of oxygen atoms. Oxygen atoms you can consider here, not oxygen molecules. Nothing but you have to take atomic weight, not molecular weight. So that what is the atomic weight for oxygen atom? Atomic weight for one oxygen atom is the 16. You should remember it. So 1 mole of oxygen atoms is equal to 16 grams. This one you already know. Then 0.2 mole of oxygen atoms is equal to how many grams? You have to calculate now. So here also you can do cross multiplication. Then you will get, see, 16 into 0.2 divided by 1. This one comes here. So 16 twos are 32. 1 point is here. So you can put point between 3 and 2. So that 3.2 grams of oxygen atoms. That nothing but 1 mole of oxygen atom having 16 grams. Then 0.2 mole of oxygen atoms having 3.2 grams of weight. This is about this problem. See here the problem is you have to calculate mass of 0.5 mole of water molecule. What is the molecular formula for water? That is H2O. Its molecular mass is 18 grams. You can note it. Okay. Then you can come to here. 1 mole of water is equal to the 18 grams. Then 0.5 mole of water is equal to the how many grams? You have to calculate. Here also cross multiplication. So that 18 into 0.5 divided by 1. So you can multiply 5 8 are 40, 5 1 are 5 plus 4 9. 9.0 grams of water present in a 0.5 mole. Nothing but 1 mole is equal to the 18 grams. 0.5 moles is equal to the 9 grams. By seeing this, you can directly tell this is the half in a 1 mole. So that you can tell 1 mole is nothing but 18. That means 0.5 is equal to the 9 grams. Here is the problem. You should calculate about number of molecules present in a 16 grams of solid sulfur. That molecules are in the form of S8 form. To this one, first of all, you should need to know about what is the atomic mass for a single sulfur atom? One sulfur atom atomic mass is equal to 32 grams. You already know. So here this solid sulfur is in the form of S8 form, so that 8 sulfur atoms mass is equal to how much? Here see 32 into 8 you can do. So you will get 8 2s are 16, 1, 8 3s are 24 plus 1, 25. So 256 grams is the molecular mass for the S8 molecule. Now coming to the point. Here he is asking number of S8 particles present in the 16 grams of solid sulfur. Now you can take this one. 256 grams of S8 molecules are nothing but 1 mole. That 1 mole of 256 grams of S8 molecules is equal to 6.022 into 10 power 23 molecules. So then what is the molecules number present in the 16 grams of solid sulfur? So here also same as usual in previous cases. So here you can do cross multiplication, then you will get your answer. 6.022 into 10 power 23 into this 16 comes to here, then 256. You can choose this 16th table. 16 1 ja 16, 16 16 ja 256. Then after you can choose 8th table. 8 2s are 16. Then you can put a point. 8 7 ja 56. 4 is the remainder. Then that will become 42. 8 5s are 40. Then 2 is the remainder, 22. 8 2s are 16. Then 4 is the remainder. Then 8 5s are 40. Now coming to, you can do this second table. 2 1 ja 2 point, 2 3s are 6, 2 7 ja 14, 2 6 ja 12, 2 2s are 4, 2 5s are 10. You can leave these two decimals for simplification. So for 0.376 into 10 power 23. From this 23, multiply with 110 to the 0.376. So you will get the answer 3.76 into 10 power 22 molecules are present in the 16 grams of sulfur molecules or solid sulfur. Here the problem is calculate the number of aluminum ions present in the 0.051 grams of aluminum oxide. What is the aluminum oxide's formula? That is Al2O3. And what is the atomic mass for aluminum? That is 27, and atomic mass for oxygen is 16. Remember one thing, this 27 atomic mass is applicable for aluminum atom as well as aluminum ions. Remember this one. Then you should calculate about molecular mass of aluminum oxide. 2Al plus 3 oxygen atoms is equal to 2 into aluminum atoms atomic mass plus 3 into oxygen atoms atomic mass. So 2 into 27 will gives you 54 plus 16 3s are 48. This will gives you 102 grams. Nothing but Al2O3 molecular mass is the 102 grams. Now coming to the problem. See, what is the number of particles present in 0.051 grams of aluminum oxide? So first of all, you should need to know about this 102 grams of aluminum oxide is equal to the 1 mole. Nothing but 1 mole of 102 grams of aluminum oxide is equal to the 6.022 into 10 power 23 particles or molecules or ions. Then 0.051 0.51 grams of Al2O3 having how many number of aluminum ions? You should calculate. Same old story here also, you can repeat cross multiplication, then you will get 6.022 into 10 power 23 into 0.051 grams divided by 102 grams. So, in this part, this one and this one, if you calculate or if you simplify these three numbers, you will get 0.03011 into 10 power 23 particles. To simplify this one, you can multiply 3 tens from this 10 power 23 to the 0.003. So, you will get 3.011 into 10 power 20. Is this your answer? No, it's not your answer, because here one aluminum oxide molecule having 2 number of aluminum ions. So, you should multiply this number with 2. So, into 2 you can do, then 2 3s are 6, 2 zeros are 0, 2 1s are 2, 2 1s are 2 into 10 power 20 molecules. This is your answer. Nothing but 102 grams of aluminum oxide having 6.022 into 10 power 23 molecules are aluminum ions. So, 0.051 grams of aluminum oxide having 6.022 into 10 power 20 number of aluminum ions. Here the problem is, if 1 mole of carbon atoms are having 12 grams weight, then what is the weight for 1 atom of carbon? You have to calculate this. You already know about 1 mole carbon atoms are nothing but 6.022 into 10 power 23 number of atoms. So that this 6.022 into 10 power 23 number of carbon atoms equal to 12 grams weight from the data. So, 1 atom of carbon is equal to 12 into 1, this 12 you can use 12 grams, okay, 6.022 into 10 power 23. So, this is the 6 2's actual calculation is, but this is little more than 6, so that you can write directly 1.99 into 10 power minus 23 grams. This is the weight for 1 atom of carbon. Here the problem is, which one is having more number of atoms. First one is 100 grams of sodium and 100 grams of iron. Among these two, which element have more number of atoms? You have to calculate. See, this one is the atomic weight for sodium and this one is the atomic weight for iron. And one more thing, you already know 1 mole of anything equal to 6.022 into 10 power 23. Remember this one. So, first of all, 100 grams of sodium you can take. We already know 23 grams equal to 1 mole. So, 23 grams of sodium equal to the 23 grams of sodium equal to 6.022 into 10 power 23 number of atoms. Then 100 grams of sodium equal to how many number of atoms you should calculate. Then 6.022 into 10 power 23 into 100 upon 23 grams of sodium. See, 23. You can write directly 23. So, first of all, you can multiply from with this 100 to this number. Then 60.22 into 10 power and one more 0 added to this 24 upon 23. Then if you calculate this number, you will get 2.6182 into 10 power 24 number of atoms. This is about how many number of atoms present in the 100 grams of sodium. Then coming to the 100 grams of iron. See, this is the iron's atomic mass. So 56 grams of iron equal to same 6.022 into 10 power 23 atoms. Then 100 grams of iron equal to how many number of atoms you should calculate. Same story, 6.022 into 10 power 23 into 100 upon 56. Same you can calculate like this. Then you will get the value 1.0753 into 10 power 24 number of atoms. So from these two numbers, which one is the highest one? See, this one is the highest one. So 100 grams of sodium having more number of atoms when compared to the 100 grams of iron. By seeing directly, see, this is the less number and this one is the more number. So directly you can tell this one is having more number of atoms when compared to iron. This is about this problem. Thanks for watching. We will meet in the next class.